Hello everyone, this is the problem of the week solution video for the problem oddities. As usual, we will read through the problem and then review a sample solution in Python. The problem description goes as follows. Some numbers are just, well, odd. For example, the number 3 is odd, not because it is not a multiple of 2. Numbers that are a multiple of 2 are not odd, they are even. More precisely, if a number n can be expressed as n equals 2 times k for some integer k, then n is even. For example, 6, which is 2 times 3, is even. Some people get confused about whether numbers are odd or even. To see a common example, do an internet search for the query, is 0 even or odd? Don't search for this now, you have a problem to solve. So as you can see right here, this is a legally binding statement expressly prohibiting such an action, which is why unfortunately this will not be part of this video. And our objective here is to write a program to help these confused people. It says here that we should expect an input that begins with an integer 1 is less than or equal to n is less than or equal to 20 on a line by itself, indicating the number of test cases that follow. Each of the following n lines contain a test case consisting of a single integer -10 is less than or equal to x is less than or equal to +10. So as you can see right here, we have our n value, which is 3, and then they also give us 3 inputs right under it. So that is doing what we expect n to be doing. And as for our expected output, for each x, print either x is odd or x is even, depending on whether x is odd or even. Okay, so we just have to tell if a number is even or odd. So let's go to our example code now. The first thing that we do in our program is we take our first number n, which is the number of inputs that we should be expecting. Remember that the input method in Python returns a string, so we wrap that into an integer cast and save that to the variable n. This gives us a number which we'll be using in line 6. You might have noticed this empty list in line 3. We'll be using this list to store our answers until the end to print them all out. If you recall from December 4th's problem of the week, which was called quick estimates, having a list and saving all of your values to it until the end could make it easier to read for the user. On the right side of the screen, right here, right now is the result from me running the code before the solution storage was implemented. And we can see that the output and user input are all squished together. So like every other line is your user input and then the output. So the purpose of this list is to move all of these result statements to the end. And we'll revisit this effect at the end of this. The next part here, starting with line 6, determines what we do with the numbers that are given. We start our loop here, which is a for in range loop, so we'll just repeat all this coding here n times, which is what we want. The first thing we do is get our number, and again, we have to cast this to an integer and save this value into the num variable. Then we get to our if statement, which pretty much does all the work in determining whether the number is even or odd. This percentage sign here is the modulus operator. It returns the remainder of a division problem. For example, if I were to do 7 divided by 4, the whole number answer will be 1 with the remainder of 3. So knowing this, 7 modulus 4 would return 3. We can use this here to determine whether a number is even or not. If the number is divisible by 2, leaving a remainder of 0, then we know it is even. So that's what's happening on line 9. If the number modulus 2 is equal to 0, then we know it is even. So we will append that to the solutions list, telling that the number is even. The opposite happens with it being odd. That's what the else statement does. One of the things that we will have to provide is an exact format. They want us to print out the original input as well as the words is even or is odd, depending on whether it's even or not. So that's why here in lines 10 and 13 we use f strings in Python to accomplish this. That stands for formatting strings. Basically, it's just a way that you can put variables in strings nearly seamlessly. Keep in mind the solution in line 10 or the solution in line 11, which we just cast our number to a string and we use string interpolation with the plus sign. These both do the same thing, so it doesn't really matter how you do it. For further resources on this, you can look up on Google, I think Python string formatting, and it'll show you a bunch of resources about this. Finally, all we have to do here, after we've appended all of our solutions to our list, is print them out. And we use this for loop, so for I in solutions, we'll print out every single solution in that loop, every single element in that loop. And again, the sole purpose of having this list and caching responses in it is just to make it look nicer. It's completely not necessary to have this, and you could replace the solutions.append statements with just print statements and get rid of the unnecessary code, and you could turn this into caddis and it would work. So that's pretty much it for explaining our problem. Let's try out the one sample input that it gave us. So let's click run here. So 3, 10, 9, and -5. So we know that 10 is even, 9 is odd, and -5 is odd. And as expected, the program performs this action. 10 is even, 9 is odd, and -5 is also odd. So that'll be all there is for this solution video. If you guys have any questions, email or remind is probably the place to ask, and I'll see everyone later.